So in this tutorial, I'm going to demonstrate how to generate PCR primers when you start from the browser view. So I've loaded up the coronavirus 2 COVID-19 genome, and you can see here the different RNA molecules that are in this orange color and the different mRNAs that are made from the genome shown here. Okay, if you want information, you just hover your mouse cursor over the RNA and it'll tell you more about it. So here, for example, is spike, or the S gene, which encodes the spike protein. And then these gray bars show um, the function of the protein in that region. Okay, so the S gene encodes the protein, and this is what function that part of the protein would have when translated. And you can see this for all of these, and that is what you will find here in the genome. But for this tutorial, I'm going to isolate the sequence for the spike protein and use that to make design PCR primers. So to do that, I go here in this region and I click and hold the mouse down and I select the S gene, okay? And so if I need to, I can come back in here and adjust these if I got too little or if I got too much. But I probably want to go slightly inside just to make sure I'm in the actual mRNA sequence, like that, okay? And now what I can do is right click on this green area here, go into the blast/primer search and go to primer blast. Okay, so just highlight again, just right click inside the green, go to blast and primer search and click primer blast. Okay, it'll open a new tab, okay, with the region, the genome accession number that we're interested in, and the region that we want to target. Okay, so here is our genome. We're targeting just this region because these numbers have been filled in for us. The primers have quite a bit of requirements, and we will discuss these in class with you, what the requirements are and what these numbers mean. Okay, one thing that we want to change is we want to go here and select the ref sequence mRNA and highlight this and delete it. And we're going to go Homo sapiens, okay, and select this one, just the same 9606. Okay, so what this is going to do is say, okay, it's going to look at all potential primers for the region that we've found, but then it's going to compare it to the human genome and say, does the primer match the human genome? And if so, throw it away. We don't want primers that will match the human genome for this case because we're targeting the spike protein, okay? And then we say get primers, and this could take a bit of time. So here are the results. So we see now in the graphical view in the browser again, here's the gene we targeted, the S gene. And below are potential primer pairs that we could select from. So these, here's primer 1, and here's the sequence for primer pair 1, and primer pair 4 would be down here, primer pair 4. Now the size of the PCR product is shown here, depends on, the one we choose depends on our application. So for our purposes, let's select a fairly large one because we'd want to see it on a gel. So this says that it's 1,775 base pairs. And this one is 1,000 This one is 73. That would be really difficult to see on a gel. 73 base pairs is just too tiny to really see on one of our agarose gels. So we want to keep it big. Let's say 2 to 300 or bigger. Okay, so 176, maybe not. So let's look at primer pair 4. Okay, it's the largest. So we'll zero in on that for this example. So here's the forward primer. And it would match the, it comes from the template, what's called the plus strand, or the sequence that's in the database. And here's this other primer. It comes from what they're calling the minus strand, which is the complement to the sequence that's in the database. And one thing we want to just double check is that the GC content is around 50%, okay, and the TM isn't too high. We don't want the TM to be much greater than 60 degrees Celsius, okay? So we'll keep it around 60. Don't worry about much of the rest of this, okay? So what you want to do for recording this for your lab notebook entry, you want to take a screenshot. So you want to screenshot this. So for a Mac, we can just do Command-Shift-4 and screenshot that, and it shows up on our desktop. Okay, and we'll just say done, and it should store it on our desktop here. So there's our screenshot. And then you'd want to copy and paste these sequences, and with the TM, okay, this is the melting temperature. So you would want to record this sequence, and the TM, okay? And that would be what you would want in your notebook. And that's the only primer pair we're going to use for this set. So there it is. That's how simple it is to identify a gene using a genome browser, and then have software pick design primers for you that you then pick based on size, maybe location, if we're interested in a very specific part of the gene. But in this case, we just wanted to detect the gene, so we went with the biggest PCR product. But in future, you may need different sizes depending on your application. So let me go back to Primer Blast now. So before, what we did is click back on this tab. We used a selected region from a browser, but we can just go right in here and type in an accession number. So if you type in some sort of accession number, and this is not a real one, I'm making it up, okay, it will look up this gene for you, and you don't need the actual DNA sequence. But in some cases, you do have the actual sequence, DNA or RNA sequence. So example here, we've got some sequence. You know, we could choose some sequence. And just like you did a blast in the past in the class, just paste your sequence in. And then if the whole sequence is okay for targeting, that's great. Then you leave these blank. But if you want only some of the sequence, then you could limit it, say, to parts of the gene. All right? So there you go. That's how you design primers.